All right. Well, I think that we have a few people, and we are going to get started here. So, first of all, I want to say welcome to Pearl Engineering's panel discussion, Safety by Design, at the 78th Annual Wisconsin Safety Council, and thank you for joining us for the virtual session. This panel will focus on how the engineering cycle is used by the disciplines of structural, mechanical, and electrical engineering to evaluate and design safety into projects on the front end and reduce the dependency on safety rules to prevent accidents and keep workers safe, hence safety by design. Our panel today is going to consist of Jeff Pearl, PE and president of Pearl Engineering. He's one of our principal consultants and specializes in structural engineering and project management of industrial projects. He's also licensed in multiple states and provinces in Canada. He's going to be representing structural. So, hi, Jeff.
Hi.
Mike Anderson is a senior project consultant with Pearl Engineering, also a PE in numerous states, specializing in mechanical engineering and project management and boilers, turbines, fuel handling, and power and industrial process systems. He has over 15 years of experience in the power industry, including 4 years in a boiler power department at a paper mill. Hey, Mike.
Hey, everybody.
On our electrical team, Susan Rice is a senior project consultant specializing in electrical engineering and mechanical, is our electrical team lead and mechanical team lead at Pearl Engineering. She is also very adept in marketing and project management in the industrial environment with experience in converting systems, food process systems, pharmaceutical processes, aerospace testing, and automotive quality control. I will be our moderator, Mike Evans. I'm a mechanical engineering associate with Pearl Engineering, specializing in project management and operation support. Overall, our panel today has over 100 years of industrial experience designing safe workspaces and clients, anywhere from 6 years to 37 years of experience. So over on our right-hand side of the screen, there are some polls that we're going to have that you can fill out along with our presentation. So we have 5 questions, and the way that this is going to go is each team lead, so Sue, Mike, and Jeff, will be answering each of the questions as we go through. So if you do have any questions, there is a Q&A section on the right-hand side of your screen, and feel free to chime in. We're going to be answering questions at the end, and definitely please chime in whenever in the middle of the presentation, and we can see those and answer them at the end, please. So the first question is, how are different standards employed to ensure that a design meets a safety standard? Provide examples of common standards in your field. And with that being said, we're going to start with Sue on the electrical side.
Thanks, Mike. The first thing we need to do is understand what the electrical scope of work is from the client. At that point, we can determine what codes we would use. Most of the time, the client will say, hey, use the NEC, National Electric Code, and OSHA, the Occupational Safety and Health Administration. But sometimes, depending on the technology, we would reference the IEEE, which is the Institute of Electrical and Electronics Engineers. And they are a great resource for technical publications and standards and best practices. So for instance, for most of our electrical design, we use NFPA 70, the NEC code. And we would use that for sizing wire or our conduit and cable design. Also working clearance, like the distance in front of an enclosure or the about the enclosures, so there's a safe distance. And if our design would be outside, sometimes we would, if there were power lines close to where we were doing our design, we would need to look at the the NEC code for the overhead power line clearance. If we were doing a new fire alarm system, sometimes we have like new buildings or like updating buildings, and we would have to add a fire alarm system. We would use the NFPA 72. And then if we were doing lightning protection system, if we were doing something like maybe a stack or a silo, something that's tall, we would use the NFPA 780 to do the lightning protection system. For instance, if we were doing a stack, like I said, another thing we would look at is the FAA Article 707460-1J. That is the obstruction obstruction marking and lighting regulations for towers and stacks for any high structures. And what that would look at is if there was an airport, how far the distance the nearest airport was, or like the height of the height and size of the structure itself. So those are a few of the codes that we use when we are doing our electrical design. Over to you, Jeff Pearl, to tell us about the codes you use for your structural design.
Well, thanks, Sue. And like yourself, in the fact that it really depends on the application, the location of the stack or the building or the piece of equipment and where it's going. Is that piece of equipment going to be inside a building, or is it going to be out on its own? Is it a standalone piece of equipment? For instance, let's say it's a tank that you want to have access to this tank. But the tank's going to come up through inside a building and come up through a floor area. So it could possibly have the building code, the International Building Code, which is typically adopted by most states, or another building code like in Canada where we work a lot. And so it might consist of, we might say we're putting a whole new floor in, and we're going to have a penetration for that tank to penetrate through to access that tank. So in that case, if it's a whole floor, which would be covered by the International Building Code in the States, let's say, then it might have applications of having two means of exiting, what does that exit look like, and that type of thing, versus if it's a partial floor and it might be considered a mezzanine, which maybe doesn't require two means of exiting, or it doesn't need two means with stairs. And then the third would be just a platform, that it's going to have an access platform mounted on the side of that tank with a ladder, which OSHA would apply in that case. So it really depends on the application, and that's kind of an example of how those would apply. OSHA, of course, would still apply as far as no matter what. For instance, on fall protection, on having an open side of that building, or an open side for, say, a lift hole where you have to have that protected with handrail and kick plate all the way around the perimeter, or tie-off points, and a means for that. So it really is some different applications on what makes sense for and what applies in that realm. How about you, Mike Anderson? You got an example for that?
For all the codes and standards that we use, it's, I guess, a good reason to look at, a good example to look at how these were developed is, like, I'm a big motorsports fan. And if you look at the way that race cars were designed 20, 30 years ago, they've made huge improvements since then. And most of the improvements they've made have been because of tragic accidents. We wouldn't have head and neck constraint devices in racing if it wasn't for some of the terrible crashes we've had. And if you look back to like the late 1800s, early 1900s, steam, with the Industrial Revolution, steam and power were being used more and more, starting to use compressed air in different factories and facilities. And there were so many explosions and so many failures where people were hurt or killed that the American Society of Mechanical Engineers had to step up, and they created the boiler and pressure vessel codes. So that was kind of a guideline for how they're going to be fabricated, what safety relief devices are required on them, and what kind of fittings, how they're going to be piped together. Then the ASME developed different piping guidelines so that you can help size the piping accordingly and use the correct materials. So, unfortunately, a lot of these codes were developed because of, fatalities and injuries. And it wasn't until the 1970s that OSHA came around. OSHA was formed. So the Occupational Safety Health Administration came along, and if they started coming up with different guidelines for what can make a system safer. Well, for example, if you look at conveying equipment, the Mining Safety Health Administration, they have much more stringent requirements for safety regulations around conveyor belts because they're using them. That's the primary means for getting the material out of the ground. So they have much more stringent requirements than OSHA. General industry is only required to meet OSHA guidelines, but several companies are adopting the MSHA or going further and coming up with their safety requirements, because all the codes and standards, whether it be National Fire Prevention Administration, they're all kind of a baseline for minimum requirements, but there's a lot more that you can do to make a system safer than just what is required by the codes or standards around your systems. Mike, do you have any other topics?
Yeah, so great insight, everybody, on the first question. Our second question is, can you explain methods employed in your design process to minimize risk? That being a risk assessment, a safety factor, or a worst case design. Jeff, you're going to start us off on this one.
Okay. Mm-hmm. And one thing, I want to go back to the codes for a second, in regard to the fact that you should understand the codes were established and have become laws and are legal regulations. And they are intended to protect both the employees who are operating that equipment and working on it to prevent injuries. They're also intended to protect the company owner, the factory owner, the stockholders, the chairman of the board, because they can be liable if their plants are not up to code and meeting the legal standards. Otherwise, it's considered negligence. In regard to how do we minimize risk, though, I think that you got to understand that in our world, we work a lot in heavy industrial facilities, like Mike mentioned, boilers, pressure vessels, chemical processing plants. And so taking those things into account in the structural aspect of just plant layout and equipment layout and means of egress from those areas. If you have a boiler that has a unit with a blow-off panel, for instance, you don't want to have your main exit path going right past that blow-off panel. So if that blew, it would cause harm to someone. So therefore, being cognizant of that, about how we lay that out, how do we make sure that we don't have a trapped area, so we don't create an entrapment. So that person, the blow-off panel blows off and there's a fire and they're trapped in the back because the only exit is on the other side of that harm's way. And further, we also work in lower risk areas that you don't think about, but they really are just as high, just as much risk. And that would be, say, in the case of wet floor surfaces or heavy traffic. So when we have an exit coming out of a building or out of an area, we don't want to have that person walk out like they're escaping a fire only to run right in front of moving traffic that's going to a tow motor racing by or a heavy truck or a train. So therefore, having guarding even in those lower risk areas that we don't think of, everything's going to blow up and catch on fire, is just as dangerous. We've seen areas in buildings that are dry as a bone and the floor is smooth as glass, and there's that thin layer of dust that makes it slippier than ice, and therefore it's just as dangerous. So how do we account for that? So those are some examples of what we do in our design process to minimize risk. How about you, Sue?
Yeah, thanks, Jeff. Yeah, what we start with is a lot of times our loads, our equipment and our loads are, you could design to either their full load amps or actually their operating amps. A lot of times you purchase a piece of equipment and you're not going to run it to full speed. So we design to the full load amps versus the actual operating amps. We also, when we are sizing conduit, we leave like a percentage of space in the conduit, and NEC has established that conduits containing one wire need to have a max fill of 53%. And if you have two wires, there's a max fill of 31%. And if it contains more than three conductors, it will have a max fill of 40%. So if the client would have something that's more stringent than that, we would follow that, but else we would follow the NEC code on that. Also, we always add a safety factor to when sizing wire. Many times, if you size to actually what your load is, and then it's decided to increase the load at that point, you're not able to do it because you've already run the wire, which could cost a lot of money to pull that. So we use usually about 80%. And again, that'll depend on what the client wants to use. But if they don't have a preference, and we usually do 80% of the load. Also, we have to take in consideration the length of the wire. If the wires say over 100 feet, we would look at voltage drop across these longer wires. And if there's enough voltage drop there, we would, which is about 3% normally, we would increase the size of the wire for that. If you can't increase the size of the wire, sometimes you can increase the size of the wire because it will not fit under your terminal block. So at that case, you would have to move an enclosure closer and maybe get a junction box, and so your wire lengths are shorter. Another thing that we do is that we always try to leave enough space in an enclosure. Say it's a drives enclosure where they can run hot. There needs to be a certain amount of airflow and heat dissipation so that we don't hurt the equipment. So that's things that we look and consider in the electrical realm. Mike Anderson, can you tell us a little bit about what mechanical design factors do to minimize risk?
If you're designing a system for a new process or to retrofit, perform a rebuild or install a new piece of equipment, your process design and the requirements around the systems, whether it's piping, sizing, the conveyor sizing, that's all calculations. That's all code based. That's rules of thumb. That's something that nearly any engineer can figure out. If you're going to actually minimize a lot of the risk around the equipment, you need to kind of understand what else is around that system, what else is around that equipment that can affect your process. Are you providing the employees that are going to be working around the system with enough room and access to work on it? If it's a retrofit project, how can you safely fit that new equipment into that facility? You also have to look at the environment. Do you need to figure out seismic loading? Are there going to be people around to where you need to have sound enclosures around the equipment? Are there potential hazardous other processes nearby? If there's acid or caustic nearby, do you need to change the base material of your new equipment, not because of the process that's affected by it, but of a nearby process that if there is a leak, you could damage that project. So you kind of need to look around what kind of traffic, either whether it's pedestrian traffic or vehicle traffic, is going to be nearby. So it's a lot more putting yourself in the position of the mechanics and the operators and figuring out how they're going to interact with that system to make it safer for everyone. Good question, Mike.
Excellent. So at this point, this is question number 3. We're going to open this up. This is our first poll of the presentation. So as we're kind of going through this with Jeff, Sue, and Mr. Anderson, please feel free to type in, what this question means to you and maybe some way that you would answer it. So this first question is, if it is not possible to make a design inherently safe, what can be done to mitigate risks? Sue, you're going to be answering this first one. And if anybody listening, we do have a couple Q&As, but it's in the poll section, and you can type your answer in the chat for everybody to see, or just the 4 of us panelists as well. So Away we go. Take it away, Sue.
Excellent. Thanks, Mike. What we do is we have design reviews. We understand what the scope is, and now we have started the design and we have design reviews. Now, the number of design reviews depends on how large the project is. If it's small, then we have less. But anyway, we say we have a 40% and then a 70% design review. Around 75%, during the time of the design, we come up with questions that would be put on a checklist of possible risk hazards. So we create something that's called the inherently safer system checklist. And then we schedule a multidiscipline meeting, a risk assessment with all the disciplines, the mechanical, electrical, and structural. We go over our design. This meeting is used to stimulate the discussion to see how we could do any process improvements to reduce or eliminate the risks. Also, this is a creative time of saying, hey, thinking outside of the box. And so we may come up with a few protective equipment that we may want to use to help with the risk, the hazard, the reduction of hazards. We might add a light current, plexiglass guarding around, say, an unwind, bollards in front of an enclosure, or near, I shouldn't say in front, but near an enclosure so nothing hits the electrical enclosure. We may need to move a remote instrumentation display so that it's and add a remote display so that the operators can, if they have to look at this display throughout the day, that they don't have to climb a ladder. So we reduce our risks in that manner. And that's what we do electrically. Over to you, Jeff Pearl.
Well, I was thinking about this question and how to mitigate risk. And so I thought I would apply it to so many plants, facilities, and even our homes. In the regard to so many facilities we work in, a lot of them are pre-engineered metal buildings with a slippery metal roof on them. And very many of them, clients have adopted to the low-cost option of mounting equipment on the roof of those buildings with the intention that, hey, I'm going to put that HVAC air makeup unit up on that roof of the building. Wow, it's free to support it up there off of the structure if it has the capacity. And we're just going to mount it up there and blow that air right down or have an exhaust fan. But like all equipment, it inherently requires maintenance and servicing, filters, systems, and things like that. And we see this so often where in saving cost of putting this unit up there, they've created such an unsafe, high-risk condition where somebody could slip and fall and roll right off the edge of the building and be hurt tragically like that. But oftentimes they could just slip and fall and break a hip, a knee, a shoulder. They could have back injuries. And so therefore, there's a lot of risk involved in just that unsafe surface. We just did a really cool project for a plant up in Canada, as a matter of fact. And it had a raised rib metal roof, and they had all this equipment up there. And we ended up developing a graded flat walk surface that actually sat right on top of the ribs of the roofing with handrails. So they could be going uphill, up the ramps, and have handrails. And then when they were going perpendicular to the slope, they could have a handrail on the downhill side. And yes, they're only 3 or 4 inches off the surface, but it's a safe walkway for them on flat walkway going perpendicular to the surface. And each piece of equipment had a walkway going down to it. It was a really cool system, and I'm really proud of that. Oftentimes we have clients that say, hey, I want a tie-off point. I want an anchor point up there. So if somebody falls, they won't die. And that's a great idea, except for the fact that how are you going to go up and get that lanyard hooked onto that anchor point at the top of the peak of the roof? So getting up there to make that anchor is a pretty tough thing. And yes, we've done tracks and cable systems and all of those types of things. But I can tell you from real life experience, because as I say about the shoemaker always has the worst shoes, I am as a structural engineer, I put a raised rib metal roof on my house, which is a really cool roof, and it's really effortless and it's self-cleaning, but it's really slippery. And I've been up there, and I've actually, because of my mountain climbing background, actually take ropes up and put them over the top and anchor them on the other side of the roof. So I'm tied off with a lanyard and a Toledo to not fall off the edge of that roof, because it's a 2-story house. But that hasn't stopped me from slipping and my feet coming right out from under me and landing on my back, to the point where I had like these parallel bruises in my back from the grooves of the raised ribs on my back. And it knocked the wind out of me. And it was a real lesson that just because you've prevented a death doesn't mean you've prevented an injury. And in our world, and we'll talk more about this later, in our world, we need to be considering about, well, what's that long-term injury, that back injury that could hurt us. So those are examples of having safe access to roofs, and part of our theme of creating safe work environments. How do we create that safe access to that piece of equipment that's up on that roof, and be economical for the client as well? How about you, Mike? Do you have some insight into that same idea?
Yeah, I mean, Mike, your question was about, how do you make a design, or how do you work with the design if it isn't inherently safe? And I guess you can do as much as you can, out front, but no system anywhere in the world is 100% safe. To make, what I've seen from my experience, to make things safer for the employees, the number one thing is to provide adequate training, whether it's the equipment that you already have in your plant or factory, or if you're installing new pieces of new equipment. If you get the operating personnel, not just to understand the operation, but to understand the normal maintenance activities that are going to be involved with it. And if you can get the maintenance personnel to understand how the system operates and how the different systems and equipment operate together, that knowledge, and them having a good understanding and feeling comfortable around the equipment, comfortable knowing that what dangers are there, that I found is the best thing to improve the safety of the equipment. But if you're looking at trying to come up with a better design, for, say you have a piece of equipment that you do have obvious unsafe issues with. So a customer had at the bottom of their boiler, they had bottom ash chutes, and these chutes were prone to plugging. And the boiler OEM, came up with an idea. Yeah, just put in some rotting taps. So they put in some 2-inch taps, so the operators would have a suit up in metal suits and rod the sand and ash out of these pipes. And the sand and ash was coming out at 1,500 degrees. So it's coming out like lava, and you're exposing the people there to this 1,500 degree sand and ash pouring out near their feet. So a lot of thought and effort was put into how can we make this rotting safer? How can we clean these chutes out safer whenever they plug, so we don't have to bring the boiler down? But we couldn't come up with any good, solid ways to do it without causing a bigger unsafe concern. What if we pressurize it? Well, then you're exposing, you're kind of pushing the limit of the design of the system then. So we looked at, kind of step back, what can we do to prevent it from plugging altogether so that we don't have to put people in that situation to rot anymore? And we developed some little teepees that would go over the chutes, like in the bottom of the furnace. It took a few tries. It was the first attempt didn't really solve the problem, but we learned from that prototype. And the second time around, it was 2 years that no employees had to be put in harm's way for that situation. So a lot of times you can make a situation safer, but it's stepping back and say, why are we trying to fix this problem when we can fix a different problem and eliminate the one we're looking at? Is that good, Mike?
Yep, absolutely. So that concludes our first poll question, and we got a bunch of feedback from everybody. So, some of the answers were provide safe work instruction, engineering controls and training, risk transfer, safe operation training, utilize the hierarchy, perform a risk assessment analysis, perhaps adding engineer controls or protective guarding, install equipment in a location that a hazard is inaccessible to workers. Another one was utilize technology to automate a process to reduce worker access. So those are all great, great responses as well.
Oh, excellent.
Moving on. Yes, thank you, everybody. Our fourth question is, why is it important to consider potential system failures during the design stage? And I believe we have a poll for this one as well. That'll be the same format as the first one that we just had. Mike Anderson, can you start us off on this one?
Basically, all systems are going to fail. All pieces of equipment are going to fail. And you don't want them to, because then whatever process you're running, your plant productivity could be down across the facility if you lose a critical piece of equipment. But so anytime you're designing a system, you're going to have different safeguards, and different things that are going to trip it out. Because if you lose a fan or a blower, whatever process that blower is supplying may need to trip to put it in a safe state. What gets overlooked a lot of times is that system is going to fail. Everything shuts down safely, but now you need to get it started back up, or you need to perform maintenance on it to try to rebuild that equipment so that you can diagnose the reason it failed, which gets overlooked a lot. If it's system trips, it tripped for a reason. So you should always find the root cause before just starting it back up. But there needs to be, manual overrides that are going to help you depressurize the line, so you can allow the operators to lock the equipment out. You need to be able to get access to clean the equipment. So say you have a slurry tank and you lost power to the system. The agitator that was keeping the slurry tank agitated, keeping it from, forming solids, you just lost that. So now you are probably going to have to take the time to clean this tank out. So knowing that you have a slurry tank, you need to make sure that you provide yourself plenty of access to drain it as well as you can. And you might need a door large enough to enter it with people so that you can vacuum it out, shovel it out, whatever you need to do. It's not just, how can a system shut down safely, but then how can you clean it out, make it safe, remove all the potential energy that's in it and allow the repairs to take place. Another important thing is, make sure that there's access around the equipment, because you're going to have routine maintenance that you need to keep up to help prevent the failures. So whether you're greasing or doing your rounds, cleaning around the equipment, you need to allow space for that. But you need to allow space for the repair. If you need to pull off a motor, you need to have space and adequate rigging for the millwrights to perform that work. Jeff, you have a lot of experience with that as a structural engineer, allowing for that kind of maintenance.
Oh, absolutely, Mike. And I think Mike is having worked for a paper company, as I have, as clients, as I like to say, when I worked as a client, I lived with all my own mistakes because you get to experience them later on. And I think that all good points Mike said about all things are going to fail eventually, and therefore planning for those. And as I've learned the hard way from working for a paper company, is the old saying about pay me now or pay me later. Well, if you're going to pay me later, you're going to pay a lot more, like 10 times more. Because, and I saw this where you have a pump located down in a basement, and it's like, wow, this is a great place. It's perfect for process on how to get this pump and how to get this piping in and out. But how are you going to get that pump out of that basement? How are you going to get that pump lifted off of the foundation and picked up? Do you have the structural capacity of the floor above it to even have the strength to pick it up? Do you have a monorail beam lifted over it, running over it? Is the piping and cable trays and everything run so thick over the top of that pump that there's not even a place to put a rod hanger up, much less a structurally stable structure to pick up, say, a 5,000 pound pump up off of its base and get it up and out of that basement? We see this time and time again, and there are emergencies, and they are system failures that become major safety violations, because we see this where clients have, hey, my gosh, we had to jury rig something and hook a chain fall here, and they're trying to swing this thing up in place, and it's a very unsafe thing, and it's very much not meeting the intent of the OSHA code as far as structural capacity of those lifted loads. So to be able to design that from the scratch is a dream come true for most of us engineers, because of the fact you can already plan and say, I'm going to have a frame built. I'm going to have a structurally stable monorail put over the top of that pump and that motor. I'm going to have it set up even with removable pipe spools over it, so we can take that piece of pipe out and lift that pump up and get it out of the way and relocate it. It's a funny joke about that. My story is that my wife, when we remodeled our bedroom recently, she had the phone jack removed out of the bedroom because she was sick and tired of getting phone calls at 3 a.m. on our home phone that was on her side of the bed, and the cord going across because we had our cell phones off. And me getting calls from clients here locally, because I'm in the phone book, and they would call and say, oh my gosh, Jeff, I've got this pump and I need to replace it. And the beam, even if the beam is over the top of the pump, it's not rated. And we need to figure a way to get this picked up. And can you help us? And I'm like, yep, I'll be over in a half hour, and getting dressed and getting through gates and the safety check-in and getting there and field measuring the beam and coming up with a size and designing it right there on their maintenance shop table and giving them something to work with so they can get that pump removed by 7 o'clock that morning. So my point is that this is all expensive to have to do after the fact. And it's unsafe because you're having to make do with what you got versus designing the safety right from the start. How about you, Sue? Do you have some insight in that same idea?
I do. Thanks, Jeff. Yes, we design fail-safe. And that is a practice that in an event of a failure, that there will be minimal to no harm to any equipment, people, or environment. What we do is we'll position our relay contacts so that in the event of a power outage or of some kind of a failure, that the relay will de-energize to a condition that's deemed safe for the application. An example of that is that in an unwind process, say we have a 60-inch roll that's 45 inches wide and the core is about 16 inches. It weighs about 4,000 pounds. And they're just as an example. And it has a pneumatic arm control. So you'd want to hardwire this so that if you had a power failure or short, that the air would be trapped in the cylinder to make sure that that fails with the arm in the up position, so that that roll is fails in the up position. Once all the moving parts come to a complete stop, usually around unwinds, there's guarding that we've designed, and the only way you can get into that guarding is to lock out air and electrical. And then at the time when you would release the air from the arm, it would slowly lower, and that would lower in a controlled manner. If you and like I said, we were doing hardwiring. If you don't hardwire and you would use your PLC to control that, you would want to make sure that you would have a UPS, which is an uninterruptible power supply, so that it would keep it powered until your generator, if you had a generator, that your generator would turn on, so that you would never lose power to that portion of it. if I would suggest that if you don't have a generator in your plant, or that you would definitely, in those kind of fail-safe environment, that you would hardwire. And that's what I have. Mike Evans, do you want to introduce the next question?
Yeah, before I do that, Sue, I want to go over some of the poll answers. So the question was, why is it important to consider potential system failures during the design stage? And we had a bunch of feedback. Avoid failures by scheduling preventative maintenance. We have process change reviews and approval processes, plan access and maintenance activities, installation qualification process to identify and mitigate safety concerns. All great things. Designing units to be fabricated safely by including anchor points in the design that the shop employees can use. Understand the user of the equipment and design the system that is easy to understand and something that the user will properly use. So again, like ergonomics, which is actually kind of leading into our last question of the day in our last poll. Another one, Brian, guarding safety circuits, interlocks, proc switches, safe access for maintenance and sanitation, e-stop placements, all great ideas. Checklists, feedback, regular scheduled maintenance. So a lot of, reoccurring words here. Creation of factory acceptance test checklists, company design standards, as well as lucrative PM schedule, FMEA, and other processes to determine modes of failure. So all really, really good answers, guys and girls. So thank you very much.
Great answer.
We're going to be actually moving on to our last question, which is number 5. Explain the correlation between good ergonomic design and safe design. Mike Anderson, you are going to lead us off on this one.
Like, safe design does take in ergonomics now. If you look at like most industries, the top causes for injuries typically strength and sprains. So that could be, not having good access to a task that's done every day, or it could be not good access to a task that has to be done because of a failure and you're reacting. If you have a failure, the people that work in your facility they're going to try to do things safely, but human nature is going to take over, and they're going to want to do their job to the best they can, and they're going to try to fix the problem. And if that involves overexerting themselves to try to reach a valve, or to try to clean underneath a conveyor, or whatever needs to be done, a lot of times they can follow all the safety rules and procedures, but they're going to overexert themselves, and that's the highest likelihood you have to have personnel get hurt in your plant. When it comes to designing for ergonomics, one piece of equipment that I've always had the most problems with are like pipe skids. It's a standard thing. You have a little valve skid that you bring in for your process, and it's built in some factory. Well, most of the time it's such a maze of pipes and valves and flow meters, and the valve that you need to get to is always the one where you're overextending and you're reaching and you're standing on a piece of unistrut to get to it. So, if the extra time can be taken, it might be a valve that needs to get used once a year during an outage to isolate the system. But still, that one person that one time a year has to stand on this piece of unistrut and reach over and overexert himself and poses himself at a risk. So it's taking the time and kind of laying that out. So that's, kind of once in a while things, but kind of just stepping back and looking at a system and thinking, all right, we have to grease this piece of equipment and there's not good access to it. Well, instead of laying down on the grating and reaching through, getting yourself kind of up and under a piece of equipment, well, can you eliminate that altogether? Can you run grease lines out a little bit and kind of have them in a standard spot so that the mechanic can stand in one spot and loop 3 pieces of equipment, or can you use auto greasers for this application? They're fairly inexpensive. Just kind of think, what else can you do for this to keep people from having to overextend themselves? Yeah, I don't know. Sue, do you have any ideas for electrical?
Yeah, electricians, operators, and maintenance folks, they are constantly exerting themselves, performing their tasks. I mean, such as, like you said, Mike, such as bending and stooping, twisting, and overhead reaching is an issue. Or by using their tools, such as like their screwdrivers and the crimpers, the wire cutters and wire strippers, cable tie guns. They have come a long way with those tools to make them as ergonomically safe as possible. But if you can do something in your design to help out with that, we're always looking for that. Even like maneuvering the unwind I told you about before, that's about 4,000 pounds. Without a hoist or clamp truck, a transfer cart of some sort, you need to have it. You need to plan and design for automatic handling of some sort. One concern is that you have a smaller injury, and you do this over a period of time, and it becomes more serious. According to the Department of Labor, in a 4-year period, they had $10 million in employee compensation claims. And it was all connected to electrical ergonomic issues. So the more we can design for that, the better. We definitely, more importantly than the money, is the people, people getting hurt and suffering. It's critical when doing electrical design to take into account not only the installation of the project, but also the operations, the daily operations and maintenance of the electrical equipment. Over to you, Jeff Pearl.
It's really cool because I'm looking over and sneaking a look at all of the answers from the poll questions here, and everybody is coming up with comments that are exactly what we're talking about here. So way cool that we're all on the same page here. And I'm thrilled to see that because it's true. Ergonomic design, good ergonomic design, is safety design. And I think the thing that's important as us engineers is understanding that what is that potential injury, and because whether the acute immediate injury of, say, a fall versus the long-term chronic injury, say, of a back injury. And ergonomics, whether it's the chair we're sitting in and what kind of chair we're using, and is that safe ergonomically from that back injury versus a lifting situation. We were just in a food plant recently looking at to help them in a safety aspect of this exact same thing. And we saw these people picking up these 40-pound bags of food ingredient powder and moving it from a pallet over, breaking it open, pouring it in, holding it, and moving back and forth with these 40-pound bags. And it just broke our hearts, like, if not our backs, thinking about, oh my gosh, couldn't we use a scissors table that we could set those bag of pallets on and have some kind of a sliding mechanism to avoid that lifting and turning aspect of moving those heavy bags? They were putting the material into 5-gallon buckets. Now they're picking up these 5-gallon buckets and carrying them and putting them onto while bending over. And so it was really disturbing to see. And us as engineers reaching out, feeling like, hey, we want to help them. We want to come up with a better solution for that. Some kind of a hoist that can pick up that bag, or something that's going to help eliminate that chronic injury. Because that's what we do. That's why we care. Mike, I think that's about all I got in that area.
Yeah, so that concludes our 5 questions for our panel here. Now, we have a bunch of replies back from that question in the polls from everybody. So the question was to explain the correlation between good ergonomic design and a safe design. Doug starts off with the good ergonomic design is one part of a safe design. It is matching the equipment with a human interface. 100%. If it isn't ergonomic, workers will be in awkward poses, which leads to extra strain and could open themselves up to injury. Yep. Good ergonomic design prevents safety incidents and musculoskeletal injuries. Good ergonomic design means that the force frequency and posture and duration of the task will be taken into account and designed into the process. Not only will that be safer, but it will lead to greater productivity. Yes, ergonomic design is just one important aspect of safe design. Engineering looks at the equipment side of safe design, and ergonomic looks at the human side. Very good. So that's like one thing of matching your cycle time of your machine equipment to what your human interface needs to be. I mean, think of a simple task of tightening a bolt. Well, it might take a human 5 seconds or 10 seconds to do that with a wrench, where maybe it takes 7 seconds with a ratchet, and it could take me 2 seconds with an air gun, but it would take a automated machine a half a second. So having the right tool for the job is always a great consideration too. The correlation is both practices have been analyzed and studied to ensure the practices are being used. Very important. Blending of making something easy to use and efficient while also protecting injuries from long-term injuries. Very important. Creating an adjustable workstation design with possible moving trip hazards, such as piping beneath conveyors, keeping controls easily within reach. All great comments.
Yep.
And we appreciate that input, everybody. We're now going to open it up. If you have any questions for us, we do have one question, and I think we kind of talked about it. It was from Joel. I think Jeff's going to answer this one. And Jeff, can you see it, or do I need to?
I do not see the question.
It's under the Q&A section, but I'll read it to you. So everybody, Joel submitted a question. One situation that we run into is fall protection on the large chiller unit or other large equipment that can sometimes be 8 to 10 feet in the air that other employees may need to be on top of to service at a client's facility. Have you had any success engineering any solutions for these types of situations, since they are usually not an integrated anchor point and there's a chance for swing falls, so a single anchor point may not suffice?
Oh, great question, Joel. And yes, actually, I don't know if you were planted in this, but we actually have a great specialization in fall protection systems, and we've done work all over, from the J.P. Morgan Chase building in New York on Times Square to L.A. airports before. We do fall protection over in airplane hangars, up in power plants, and in all types of facilities. We work with other safety suppliers that supply tracks and cable systems and fall protection systems to really custom design solutions for fall protection. And in that case, we really found that the sliding track systems really work great where you can fit them in. Actually, I was going to use a fall protection example for that one earlier on how do you do the best you can in regard to designing if you can't design completely safe. But with fall protection systems, we do have a specialty in that area. And there are some really creative ideas on how to do that with track systems, with tie-off points where you might be climbing a ladder to get to the spot on a fall protection track or cable on that ladder, and then you tie off to a separate anchor as you step onto a floor, then you tie off to a fall protection track that would go over that piece of equipment. And using retractables are probably the only way to go anymore. We really love retractables because they really limit that distance of fall and really can prevent back injuries and be much more of a tether with quick locking system. So I'd be glad to talk to you about that later if you'd like, Joel, to discuss that. Thank you for asking that question. It's a great question.
All right. I do not see any other questions coming in at this time. If anybody does have any, please feel free to type those in the Q&A or the chat. One thing I also want to, another person I want to mention today is Scott Burkart. He has 36 years of experience and has been with Pearl Engineering for 5 years. He's a senior safety consultant with us, and he was also a deputy fire chief in Eau Claire, Wisconsin for the fire department there. And prior to his retirement there, he had joined us, like I said, 5 or 7 years ago. And Scott is a real life superhero. He is inducted into the Hall of Fame, or the Firefighter Hall of Fame, for actually saving a child from a burning building. So fun fact about Scott Burkart. He's a great guy, and he does a lot of our on-site safety. I know in our booth, we do have our on-site safety consulting kind of PDF, and I did notice that has been downloaded a lot. So if you have any questions about that, we would love to talk to you guys about that. However, I will put my contact information in the chat here briefly. Otherwise, see us or join us over at our booth at just the Pearl Engineering booth, and we can schedule a time to continue some conversations, or we can get you guys can get our email and our cell phone numbers, and we would love to have a virtual call with you and see what your guys' needs are. So we really appreciate that. And Jeff, I know you have some closing remarks, so could you please take it away?
Thank you, Mike. Thank you for moderating this for us today. I very greatly appreciate it. And I think that, as you can tell by our stories and our experience, that Pearl Engineering is very passionate and committed to the safety of employees in industrial plants that we work for. And like I said earlier, not just for their safety, but also for the protection of the company owners in that aspect of work loss injuries and that aspect. We care about people. We're proud to make a difference in preventing somebody from being hurt. With having our own in-house safety consultant like Scott Burkart, we do very much consider safety in our own designs, and being able to have him review things and saying, hey, we're designing a platform. Here's where this is going to be. What do you think about this? And him having that safety aspect inherent in our designs for the work we do for the clients and work. And like I mentioned to Joel, we do a lot of fall protection and platforms. We have a theme we call creating safe work environments that we're very proud of, where how can we make that a safe platform with a station to work from. So we're very proud of that. In addition, like I said, safety is inherent in our work, and it should be in any client's work. So whether you use us or another engineering firm or a maintenance group or a contractor, always please consider safety in that installation. Finally, our final recommendation to all clients is, if you don't already do this, have a safety advocate on your side that's working with the engineering design and with the contractor in your work, because it's just so important. And having that person to second guess that, to say, well, how's that going to work? How are they going to be safe? How are they not going to have to be down on their knees on this sharp grating to get this done? Are they really going to tie off every time? So please consider that in your work. We thank you very much for your time, for letting us join you in this morning. And we hope we've been of good value, and we wish you all to be safe and happy. Thank you very much.